Hello, today I'm gonna review about the channel effect related to last video. First is the velocity saturation. So when channel is long, we can write the velocity is mobility applied the electric field. But when channel was shorter, the electric field will be very stronger. So the carrier scattering is increased, so mobility is go down. So velocity is not linear to electric field. So when electric field is critical electric field, the velocity is saturation. So when the long channel, we can see the current is proportional to VGS minus VT squares, but in short channel, it is linear to VGS. So the one current of the transistor is go less when short channels because it's linear only VGS. Next is the gate-induced drain leakage. When we apply the minus voltage to gate, the thickness of the energy barrier is very thin, so you can see the graph when we apply more higher negative voltage. The leakage current is go higher because the potential barrier go more thinner, so carrier can be tunneling to conduction band. Next is the pocket implant. Is implant the pocket shape, the highly doped, the same type of the substrate. So it can prevent the punch through and VT roll off because it defends the depletion region go wider. So the source and drain's depletion region cannot overlap. They can prevent the punch through and VT roll. Next is the resistance of source drain series. First is the contact resistance, is resistance between metal and silicon junction, so it makes the Schottky barrier. And next is sheet resistance, is resistance in source and drain. And spread resistance is resistance when the carrier go source or drain by two channel. So source and drain is very wide, but channel is very thin, so it causes the bottlenecks. So the spread resistance is the main thing of the source drain resistance. And next is excess carrier resistance, is when we implant the LDD. So when carrier moves the N plus and by N, so the doping concentrations go down, so resistances go up. Next is the contact issue. So the transistor go smaller and source drains, the contact region will be also thinner, so the contact resistance go higher. And we should we make those series resistance go smaller because we have to reduce the time delay. Next is the ratio. Ratio is in CMOS, the junction of the NPN and PNP is turned on by the noise or high voltage. So when those NPN and PNP BJT turn on, so it causes very high current, so it breaks the transistor. So to block this red shot, we make the STI and DTI. This is the STI, the shallow trench isolation, to block the leakage between source and drain. And DTI is deep trench isolation, to block between NMOS and PMOS. So it make very deep, more than N wells with this. So it can block the ratio. Last one is the high K metal gate. When we make the transistor the high performance or smaller, we should increase the COX. To increase the COX, we have to reduce the thickness of the oxide. But when we reduce the thickness, it can cause the tunneling. So it have the limitation of the thickness. So we have to make the oxide the other material. You can write the epsilon is K epsilon 0. So we have to make high K material to increase the capacitance of the oxide. Thank you.